Everyone, welcome back to another video. The sponsor of today's video is Isaac Newton. Hooray! Okay, here's our acceleration graphs worksheet. I want to remind you it's all the same equations up here, so that should be pretty easy to do. Wow, I really didn't mean for that to happen. There we go. Okay, for these graph problems up here where it says draw the corresponding velocity graph or draw the corresponding position graph, you should have the answers for all these in the papers that you're using for that big lab we did with the carts and the tracks. So just check in with the people who you did that lab with. Somebody should have a big set of papers there, and you should be able to find the answers to these in amongst those papers. I think these first problems are pretty easy to do. When I say something like plot 6 points, then it might be nice, it might be nice to have a table, draw a table first, and you're basically going to be using this formula here. Why does that happen every time? Okay. You're going to be using this formula 6 times to make 6 points. Same with over here, you're going to be using this velocity formula 6 times. And remember that your position graph should be curvy like a parabola, and your velocity graph should be a straight line. This one, similar thing, drawing just the velocity graph this time using 1 second intervals for time. Remembering that up here I say be careful with the plus and the minus. Let's see if it fills it in. Why? Don't fill it in. Okay. That when you're slowing down from 50 to 0, your acceleration is going to be a negative number, as long as this is going in a positive direction. For these right here, find the area under the graph. So we did this with velocity graphs in the past, and excuse me, that when you find the area under a velocity graph, that's going to represent the displacement or the distance that you go. So that's what it represents. And finding the area is going to be finding the area of a triangle this time. So you'll have to remember, how do you find the area of a triangle? You should be able to remember that from math class or look it up. I do want you to do these extended problems, of course. So this one is going to kind of be 3 pieces. You've got first the car starts from rest and accelerates. Then you've got driving at a constant speed. And then you've got slowing down and stopping. So it's like 3 different parts of a graph. So on your velocity graph, you should have 3 distinct sections. And of course, that's going to meet together. So you're going to have something that is accelerating, and then constant speed, and then slowing down and stopped. Once again, you're going to find the total area under the graph, break it into 3 sections. And just to give you the answer to this area represents the displacement, or the distance that the car travels. Okay, with the buggy and the pullback truck, so you're going to be doing a position versus time graph. So I'll just kind of draw some axes up here. You got that, and you got that. What's going to be necessary is to have one of them going kind of in the negative direction. So my suggestion would be maybe have your buggy, since that's the one at a constant speed, make that one going in a negative direction. So it's going to be kind of coming down like this. And then the pullback truck can have an accelerated motion that's going to kind of be a curvy thing, something like that. So I do want you to plot points for it, and you're going to have a starting position for one of them, which is going to be 6 meters up on this axis over here. So that's the general shape that this graph is going to look like, and then where they kind of collide, and you can kind of estimate this collision. I would rather have you plot points than just go to Desmos on this one, because I kind of want you to just have practice using the formula. But I suppose if you just plot it on your graphing calculator or Desmos and then draw it in here, then that'll probably be okay as well. Okay, once again, this is going to be a velocity graph. And remember, when you're slowing to a stop over here, you're going to have a negative acceleration. So just make sure your graph depicts something that has a negative acceleration. Find the area of your graph, and then also, since the area under the graph represents the displacement, then I'm going to want you to use this formula right here, keeping in mind, keep in mind that when you use this formula, you will have an initial velocity. Oh, it's buried back under here. So you will have an initial velocity of 40 meters per second, so that does need to go inside of here, and your acceleration will need to be negative inside of here. So just pay attention to those things. And I believe that that's it, right? Some of you may have gotten challenge problems printed on the back of yours and some didn't, so feel free to look at the challenge problems if you want. So overall, I don't think this is an extremely hard worksheet. Of course, if you've got questions, you can email me a question or come try to see me during office hours.